Hello everyone, welcome to this new video. So in this today's video we'll be solving the problem determine if a cell is reachable at a given time. So this is a medium level problem and is the problem of the day on Leetcode. Unfortunately we do not have the company tags for this question, but it's been noticed that this question has been asked recently in the Leetcode weekly contest 361 or 362. I don't remember it properly. So this is a medium level question, but to be honest, it's very easy once you actually try run the actually manually solve this question. Once you solve this question with 3 or 4 examples, you'll yourself understand what is the logic here and you'll frame the code accordingly, and it's too simple. All right, so what is the question? So you're given 4 integers sx, sy, fx, fy and a non-negative integer t. In an infinite 2D grid, you started the cell SXSY. Okay, this is the starting point SXSY. Each second, you must move to any of its adjacent cells. Alright, so return true if you can reach FY after exactly t seconds, or false otherwise. So this might be confusing at the very first instance, but if you actually manually solve this question, try solving this question, then you'll understand, and even the sample examples will give you a lot of clarity. Alright, so let us see that in brief once we actually solve this sample examples. So A cells, adjacent cells are the 8 cells around it that can share at least one corner. All right, so you can visit the same cell several times as well. So this is also one of the key point that can be noted. So because of this condition itself, you can actually solve this question. All right, so thing is here all the 8 cells. So it's an infinite grid matrix, so all the 8 in the sense left above, top left, top right, down, bottom left, bottom right, and left and right. So total is 3 plus 3 plus 2, that is 8 cells are all adjacent. Great, so that is also one of the key point to be noted. So these are the sample examples that's been given, and these are the constants. So t goes up to 10 power 9 and all these values also goes up to 10 power 9. So this might create some confusion at the very first point, but need not. Once you start solving these examples, you'll be getting a lot of clarity. So let us go through the example. Let us go through these examples now. So this is the example 1. All right, so this is the start point, this is the finish point, and in this case the output is true. All right, the output is true. But how is it so? Let us observe this. So from this start point I'll be going to this point, and from this point I'll be going to this point, from this point I'll be going to this point, and then I'll be diagonally visiting this point, and then I'll be going to this point, and then diagonally visiting this point. So what is the time that's been consumed here? So make a note of this particular thing, that each step going to cost you 1 second. All right, so here it's going to cost me 1 second, 1 second, 1 second, 1 second, 1 second, 1 second. So how much is the total time consumed that's been there here? T equal to 6 seconds. All right, totally have consumed 6 seconds, and according to the question that's been given, I must be able to reach the finish within after exactly t equal to 6 seconds. So yes, I am able to do it, so I am returning true. All right, so coming to the example 2. So example 2, this is the start point. All right, this is the start point and this is the finish point. So how can you reach the start like this finish from the start? So this is one of the most optimal path. So here coming to this, and from this, and from this. All right, so what's the time that's been consumed here? 1 second, 1 second, 1 second, 1 second, total t equal to 4. All right, t equal to 4. So totally 4 seconds have been consumed here. But according to the question given, we must be able to reach the finish in t equal to 3 seconds after exactly t equal to 3 seconds. But we are reaching the finish in the most optimal path. Okay, this is time for most optimal path. Okay, time for most optimal path. Okay, time of, it's not for, time of most optimal path. Okay, time of most optimal path, and that is actually giving you 4 seconds. So no matter what, you cannot reach the finish in within 4 seconds. Great, so only after exactly 4 seconds you can reach the finish. But in the case, in the question, it's been given t equal to 3, so we'll be returning false. All right, so this is the basic funda. That's it. This is the only thing that we are required to do. Return true or false. Return true when you're able to reach the destination or the finish after exactly t seconds. Return false if you are not able to do so. So what are the observations that we need to make a note of? All right, so there are 2 observations, I would say, maybe 3 also. So what do they mean by after after exactly t seconds. What do they mean by that? All right, so let us take an example. I have a start here, I have a finish here. All right, and the question says you must reach the finish from start after exactly 7 seconds, but I found out that the most optimal pathway from start to finish, okay, this is the optimal pathway, let us assume I'm taking, or maybe if you want to take this, you can take this, and I'm saying that the most optimal pathway is only costing me t equal to 3 seconds. All right, in t equal to 3 seconds I'm able to reach the finish from start. So should I return true or false in this case? Should I return true or false? This is the question. I would say return true. Why is it so? Why should we return true? Go through the question again. You can visit the same cell several times. All right, you can visit the same cell several times. So let us take this normal example. All right, you're in Hyderabad. All right, and you want to go to Visakhapatnam, and you're at you have 8:30, like you're in some place in Hyderabad, all right, and it's 8:30 a.m. and your train is at 12 p.m. all right, 12 p.m. and the time it's going to cost for you, all right, the time you're going to take to reach from your place to Hyderabad railway station. All right, so you're at some place in Hyderabad. All right, you're at some place in Hyderabad. All right, some place in Hyderabad, and now you want to go to railway station. Okay, railway station to Hyderabad, in Hyderabad. All right, railway station in Hyderabad, and you see that the most optimal time that's going to take that you're going to take is just 2 hours. All right, 2 hours. All right, so it's only 2 hours that you're going to take to reach Hyderabad railway station from your place that in Hyderabad. All right, 2 hours. So if I start to railway station at 8:30 itself, then I'll be reaching my railway station at 10:30 a.m. itself. All right, 10:30 a.m. So what I'll be doing is, I'll be saying, instead of just starting at 10:30 a.m., I'll start at some other time, just before 2 hours, before 12. That means at 10 I'll start. All right, at 10 I'll start, and before that I'll roam to some other places and come. I'll roam to some other nearby places. I'll enjoy myself, and then correctly at 10 a.m. I'll start to railway station, and it will cost me 2 hours to go to railway station, and then I'll be getting into the train that is at 12 p.m. all right, similar is the case here. All right, so similar is the case that we can find here as well. So it has been told that t equal to 7 seconds, you need to after t equal to 7 seconds, exactly t equal to 7 seconds, you must be able to reach the destination. So, and you found out that most optimal path that is actually you're going costs only t equal to 3 seconds to you. Only 3 seconds you'll be able to reach the finish. So in the other time that's left, you can go to some other places, and you can go to some other places, like go to this place, and then from there you can come to the finish. Similarly, you can go here, and then you can reach the finish. So that is the reason we'll be returning true. So you'll be spending rest of the time visiting some other places, some other grids, some other boxes, and then you'll be reaching the finish after exactly the time. So such that the total time that you're going to take would be t equal to 7 seconds itself. So whenever I find that the time that I'm going to take to reach the finish in the most optimal pathway is less than or equal to the given time, then I'll be returning true. All right, I hope you people understood this. So that is the reason they mentioned you can visit several other cells, you can visit other cells several times. Okay, you can keep visiting the other cells, and after exactly 7 seconds you'll be reaching the destination. So that is one of the points that need to be noted. All right, so this is the main thing. And second thing, this is the crux of the approach. What is the most optimal pathway? How do you figure out the most optimal pathway? How do you figure out this? Okay, how do you figure out this? Let us clearly see this here itself. All right, let us clearly see this here itself. When I say most optimal pathway, you would be looking out to go in the diagonal. Right, you'll be looking out to go in the diagonal, isn't it? You'll be looking out to go in the diagonal. If you go to the left or you'll be going to the right, you're actually spending a lot of time. Instead, if you go in the diagonal, you're covering a lot of distance. Covering a lot of distance in the same time. So let us assume you want to come here. All right, you want to come here. So this is the finish, right? This is the finish. For reaching this finish, you need to come at this position. I mean, this particular row. So when I say instead of going down, I'll be going in the diagonal. Okay, I'll be going in the diagonal. So if I go in the diagonal, I'm reaching this particular point through which I'll be reaching finish in just 2 seconds. But what if I reach here? From this, I need to go to this particular thing, this particular thing, this particular thing, this particular thing, this particular thing. It's costing me around 5 seconds. 5 seconds just to travel from this particular point. Just to travel from this particular point to this particular point. But what if I land here? What if I land here? In that case, it's only costing me t equal to 2 seconds. So I hope you people are understanding. So when I say the most optimal path, you would be looking out for the diagonal distance. All right, you will be looking out for the diagonal distance, because that's a freedom that's been given to you. You can visit any of the adjacent cells, so you can keep on going diagonally. You can keep on going diagonally, and you will be reaching till that point that you can go diagonal. So it's not like let me erase this part. It's not like you'll be keep on going diagonally. All right, that's not going to work. You'll be going diagonally up to only some certain extent. So you'll be going to diagonally only till this particular point. It doesn't make any sense for you to go here and come back, right? It's going to take almost the same time in the most optimal pathway as well, but still you'll be following the diagonal pathway only up to certain extent. But what is that certain extent? And after once you reach that particular endpoint, this is the end of the diagonal pathway. What is the remaining distance that you are going to travel? All right, so that is what you need to make a note of. So how are you going to deal that? If we clearly observe, all right, so here the time that's going to take is 3 seconds. All right, t equal to 3 seconds, and the time that's going to take here is 1 2 3 4 5. All right, t equal to 5 seconds. All right, t equal to 5 seconds. So when you're actually going in the diagonal pathway, if you see, you are actually consuming the minimum of among these two. All right, minimum of 3 and 5. What is minimum of 3 and 5? Minimum of 3 and 5 is actually 3. All right, minimum of 3 and 5 is actually 3. So when you're actually reaching this particular point, you, instead of traveling in this particular position, you have in this particular bottom vertical pathway, you have used diagonal pathway, and in the same time that t equal to 3, you have reached the far more closer distance to the finish, far more closer grid to the finish. All right, far more, this is much more far closer than this particular grid, right? So you have actually reached this in the same time, like minimum of the vertical down and the horizontal right. All right, so there are two ways that are possible to you. You can come down and you can go right. So I'm saying here it's going to take t equal to 3, here it's going to take t equal to 5. And when you're actually following this diagonal pathway, you're able to reach this particular point, which is much more closer to the finish. Let us assume this is a finish. You're able to reach this in what time? T equal to 3 itself. All right, t equal to 3 itself, t equal to 3 or steps equal to 3, in like 3 steps. All right, in 3 steps you're able to reach, because this is the minimum among 3 and 5. Among 3 and 5, what is the minimum? This is the minimum. So in that minimum, you're able to reach something that's closer to the finish, and that you're reaching through the diagonal pathway. And what is the remaining distance? This is the remaining distance. How do you figure out the remaining distance? Because now you have traveled 3 steps already. All right, now we have traveled 3 steps already. So what are the remaining thing? So this is the remaining thing. All right, this is the remaining thing that you need to travel. And originally it was 5. All right, originally it was 5. If you were like here, you need to travel 5. Now because you have reached here, this particular point, what is the remaining thing that you need to travel? That is 5 minus 3, that is actually equal to 2. All right, I hope you're getting my point. Before, if you were actually following the conventional pathway, you would have traveled from this particular point to this, and from this particular point you would have traveled to the finish. So here it's going to cost you 3 seconds, here it's going to cost you 5 seconds. But now because you have traveled in the most optimal pathway to this particular point, all right, to this particular point you have traveled, you have come to this particular point, so that is actually costing you t equal to 3. All right, t equal to 3. And now what is the remaining thing that's left? So the diagonal pathway, the bottom pathway, you have already covered. So this is the bottom, like bottom vertical that you have already covered. Now the only thing that has been left to you is to cover the horizontal distance. No matter what, to reach the finish, you need to do some sort of bottom vertical down steps and horizontal right steps. Now because you have covered the minimum among these two, that is the vertical down steps, you have already covered. Now the only part that has been remained to you is to cover the horizontal thing, because when you're actually going to diagonal, when you're actually going the the diagonal, you're finishing both. So I'll be writing this statement here. When you're going through the diagonal, when you're actually using a diagonal pathway, you're covering both vertical and horizontal. Both vertical and horizontal, isn't it? When you're actually going in the diagonal pathway, you're covering both vertical and horizontal. That is the reason when you're if you take the minimum of these two, so in 3 seconds you're covering down 3 steps, and you're also covering 3 steps in the horizontal. You're covering the 3 steps in the horizontal, you're covering the 3 steps in the vertical. And now the only thing that has been remained is that is the horizontal, you still need to travel 2 steps. Alright, because 5 minus 3, that is equal to 2, and that is the remaining thing. So total time that's been consumed here is 3 steps in diagonal plus 2 steps in horizontal. Total 5 steps or 5 seconds. Alright, 5 seconds. So this is less than or equal to the target that's been mentioned, that is 6. So you can return true. I hope you are able to understand. So when you're actually following a diagonal pathway, you're covering the both vertical and horizontal. So no matter what, to reach the finish, you need to travel horizontally and vertically, isn't it? You need to travel some horizontal steps and vertical steps. No matter what, that would remain the same. So now you're traveling in the most optimal pathway in the diagonal pathway. When you're doing the diagonal pathway, you're covering both vertical and horizontal. So you need to reduce that particular amount from your bottom target and your right side target, and remaining thing is what that you need to travel. All right, I hope you understand, you're able to getting my point. So even in this case as well, so this is the diagonal pathway. So in this case you're taking t equal to 2 seconds, and the remaining that's been there. So here originally it's going to cost you 1 second, 2 second, 3 second, 4 second. So you have already traveled 2 seconds. You have already reduced the horizontal by 2. Only thing that has been remained is 2 horizontal. So 2 plus 2. So 2 plus 2, that is actually equal to 4. But that is actually greater than 3. So that's the reason we return false. I hope you are able to understand. So when you're actually going down, that is going to take 2 seconds itself. So in the diagonal pathway, you have covered both vertical and horizontal. Both you have covered. So that is the reason you need not do any vertical anymore, because that is the minimum thing out of the vertical and horizontal target. And you have in the diagonal thing, you have already covered the vertical part. There's nothing there to cover the vertical, only horizontal, because when you're coming here, there's only straight line that's there, horizontal thing that's there to reach the finish. You need not travel from here and here. We are not looking for all the spots. We are looking for the optimal path. So you can just need to go in the straight line in the horizontal, so that the target remaining is like 4 minus 2, that is equal to 2. So 2 plus 2 equal to 4, and that is greater than 3. So we written false. I hope you people understood the approach. So it's basically finding out the minimum among the vertical target and the horizontal target, and that once you found it, you'll be using a diagonal of that length, so that you'll be covering one of those two things, and the remaining thing is what you'll be covering in the horizontal or the vertical. Just a straight line, either vertical you'll be going or horizontal you'll be going after covering the diagonal pathway. I hope you understood. So this is the code for that particular thing. So let us first thing is to actually calculate the absolute distance between the end point x coordinate and starting point x coordinate, similarly with the y itself. So we are finding the horizontal target and vertical target. Okay, vertical target, we are finding both of these values, and now the minimum of those, okay, minimum of these things is are we going to take, and that is what we are going to cover through the diagonal. This is the diagonal distance. Okay, this is what we are going to cover in the diagonal, and the remaining distance that we need to travel is like subtract that diagonal from horizontal and from vertical. Okay, subtract that from the horizontal and from vertical, and that is the remaining distance that you need to travel. And if you see the max of remaining x plus remaining y, that is the maximum of both of them. So one of them would be 0. So after traveling the diagonal path, one of them would be 0, that's for sure, right? So minimum is what we are taking, and we are subtracting from the thing. So one of them would be 0 and the other one would be there. If remaining y is 0, like remaining x would be there, or if remaining x is 0, remaining y would be there, and plus minimum distance. This is the diagonal distance. Okay, distance, and this is actually turning out to be 0. If this is actually turning out to be 0, that means this total sum is turning out to be 0, means your starting point is actually equal to your end point, right? Your start, like this is finish and this is start, both of them are same. Like let me write this properly. So both of them, like this is the start and this is the finish, both of them are the same point, right? If you are getting your minimum distance plus max of these two is 0, that means your coordinate, let us assume your starting coordinate is 2, y equal to 2, and same like end is the 2 and end x is equal to end y equal to 2. Let us assume this. So when you subtract these two, you'll be getting 2 minus 2 comma 2 minus 2, that is actually equal to 0 comma 0. So that means you have got the minimum of them, the total distance between them to be 0. All right, the total distance between them to be 0. Now if they're mentioning that after exactly 1 second, after exactly 1 second you need to reach, that's not possible, because if you are at this particular point and you need to reach at that particular point itself, if it is t equal to 2, then you can go to some other grid in t equal to 1 and you can return this, come to this in t equal to 2. And let us assume if it's t equal to 3, I'll be saying from this particular grid I'll be going to this grid, and then I'll be going diagonally to this grid. In t equal to 3 is also possible, t equal to 4 also possible, any t is possible except t equal to 1. If it's t equal to 1, in t equal to 1 second you'll be going to some other grid. And how can you return to the grid after just exactly 1 second? You have been displaced, from your start point, but here your start point is same as the end point, so you cannot reach it in just 1 second. It's not possible. So if t not equal to 1, then we return true, else we return false. All right, and this is the total distance or the total steps or the total time. So max of remaining x comma remaining y, so the remaining distance plus the minimum distance, this is the diagonal. Okay, this is the diagonal distance, and this is the horizontal or vertical, depending upon which is maximum, horizontal or vertical. And if this is less than or equal to t, then we return true, else we return false. All right, so that's the basic code. I hope you people understood. So nothing much to confuse. If there is any sort of confusion, please watch the video once again. And for your reference, codes in Java and Python, C++ are given in the description. Please go through them and let me know if there are any doubts through the comment section. Thank you for watching. Stay tuned.